Good afternoon, everyone. Welcome back to the 4-day online workshop on statistical analysis and its interpretation using R and SPSS, organized by the Internal Quality Assurance Cell, Christnagar College, Maranallur. Before we begin the session, I'd like to remind you some instructions and rules about the session. The link for each session will be posted 10 or 15 minutes before the session commences. Besides Zoom platform, the participants will be given the YouTube live link. Kindly mute your audio and video during the session for better experience. The feedback link will be posted at the end of the final session on Zoom as well as the YouTube platform. Certificate will be provided to the participants on the basis of their attendance and the feedback they submit. And finally, you're requested to check the messages in the WhatsApp group regularly, as we'll be sharing the information, the day-wise schedule, and the links regarding the FDP there. So yesterday, in the previous session, we had a great talk on the basic statistical concepts and its application by Dr. Irshad M.R., the Assistant Professor, Department of Statistics, CUSAT, Cochin. Today, we are going to deal with the introduction to statistical inference. And it's my pleasure to welcome Irshad sir again to begin the session. Over to you, sir.
Thank you. Okay, good afternoon. Can you see my screen?
Yes, sir.
Okay. So yesterday we have discussed some basic concepts of statistical analysis and some interpretations. Today, I have planned to discuss some basic statistical inferential aspects. Okay. So, first we discuss the concepts called random variable. What is random variable? Yesterday we discussed what do you mean by random experiment. In every random experiment, we have a sample space. For example, for a coin tossing experiment, we have the sample space. Sample space means set of all possible outcomes. In the case of coin tossing experiment, sample space contains two elements, that is head and tail. Okay. Similarly, in the last example discussed yesterday, sample space contains infinite number of elements, that is the sample space corresponding to waiting for a taxi problem. In this case, sample space is equal to set of all t such that t greater than or equal to 0, where t is the time points. In this case, sample space contains infinite number of points. So, what is random variable? A random variable is a numerical aspect or measure of the outcome in a random experiment. Random variables are generally denoted by capital letters X, Y, etc. That means every random experiment corresponding to a random experiment, we have a set of numerical aspects. Simply, it is called a random variable. It is denoted by capital letters X, Y, etc. We have two types of random variables: discrete random variable and continuous random variable. If the sample space contains finite number of points, the corresponding random variable is discrete. If the sample space contains infinite number of points, as mentioned earlier, the corresponding random variable is continuous. Okay. So next is, for introducing some concepts of statistical inference, we want to know at least two basic probability distribution. Actually, what do you mean by probability distribution? Probability distribution is a mathematical function, a probability function corresponding to a random experiment, is simply known as distribution. Okay, that is a mathematical function corresponding to a random experiment is simply called it as distribution. First basic distribution is binomial distribution. Okay, so what is binomial distribution? So binomial distribution consider a random experiment with only two possible outcomes. That means, for example, coin tossing experiment. We know that in a coin tossing experiment, we have only two possible outcomes, say success and failure. Suppose head is the success and tail is a failure. So we have two possible outcomes in a coin tossing experiment. In every trial, that is in each repetition, we have a probability P. That is, the probability of success is denoted by P. That is, probability of getting failure, probability of getting success is P, and the probability of getting failure is 1 minus P. Consider n independent trials are considered. That means consider n independent trials. That is simply, suppose we have conducted a coin tossing experiment, say 10 times, n is equal to 10. In this case, what is the probability of getting head? That is, what is the probability of success? Is simply obtained by due to binomial distribution. That is, actually binomial distribution says, consider a random experiment with only two possible outcomes. Let B be the success probability and 1 minus P with the failure probabilities. Let n independent trials be considered. Out of these n trials, K success can be obtained by due to this probability. This function, that is, this is known as simply a binomial distribution. So the situation, so the random experiment corresponding to a binomial distribution is a random experiment with only two possible outcomes, with the success probability P and failure probability 1 minus P, and n times this experiment can be repeated. Out of these n trials, K success can be occurring NCK ways. This is NCK. So this is the probability function of simply binomial distribution. I have given an example here. What is the probability that in a family with 5 children, 2 are girls? So problem is very clear. Here we have 5 children. So n is equal to 5. Our interest is, what is the probability that 2 are girls? Okay, we know that here we have two possibilities, male or girls or boys, that is male or female. So each with the probability 1 by 2. We have only 2 chances. So each with the probability 1 by 2. So probability of success, that is 1 by 2 only, because we have 2 chances. Similarly, probability of failure. So probability of success means probability of girl students is 1 by 2. Similarly, probability of failure is also 1 by 2. So this is P. N is equal to 5. P is equal to probability of success is 0.5. Probability of failure is 0.5. So substituting these values in this equation, we get the required result. That is, we want out of 5 children, 2 are girls. So 2. X is equal to 2. Probability that x equal to 2 is equal to 5C2. 5C2. That is 5C2 means 5, n is 5, k is 2. Because we want the probability for 2 girls. So n is equal to 2. P is the probability of success, its value is 1 by 2. 1 minus b is again 1 by 2. N is 5, k is 2. So this is equal to 3. So computing this, its value is 5 by 16. 5 by 16. That means this is the probability. That is, what is the in a family with 5 children, the probability of 2 girls are 5 by 16. Okay. Similarly, we consider other probabilities also. The probability of having all girls, that means in a family, we have 5 children. The probability of 5 are girls is equal to 1 by 32. So that is substituting k is equal to 5. Similarly, no girls. No girls means x is k is equal to 0. So it is also 1 by 32. This is the way of finding binomial probability. Okay, so if this is a random variable, this follows binomial distribution, then the average number of success is simply obtained by NP, is obtained by this equation NP, and its corresponding standard deviation is n root of NP into 1 minus p. That is, in every random experiment, we have average value, that is NP, corresponding standard deviation. In the case of binomial probability, this is equal to NP, and standard deviation is NP into 1 minus p. This is a mathematical expression only. Next one, important distribution is what we mean by what is called a normal distribution. Normal distribution is very important for every statistical analysis. That is why I have included this here. Because every statistical analysis, behind every statistical analysis, we need a distribution assumption. That is, what is the actual distribution the data follows. This is an important thing for analysis of data. So this is very important in the in statistical inferential aspects. So what is called a normal distribution? Simply, it is a mathematical function. It's a representation. Its mathematical form is 1 by sigma root of 2 by e raised to minus of x minus mu the whole square by 2 sigma square. This is simply a mathematical function. Okay. So what is the peculiarities of this function? Okay. This is very useful continuous distribution useful to model many data sets whose frequency curves are approximately bell-shaped. That means yesterday we have seen that how to write a histogram corresponding to a data. That is, if we have write a histogram for a given data, we get it is in the bell-shaped form. That is, data is in bell-shaped. We may conclude that the data follows normal distribution. Simply, what is the meaning? So we have a data, write an histogram corresponding to that data set. We get a bell-shaped curve. We may conclude that the data follows normal distribution. Okay. Here, because the shape of this function is bell-shaped. Okay. That is, the frequency curve is symmetric around a single peak at the center, and the frequencies decline rapidly as we move away from the center. Okay. Okay. For instance, the heights, weights, etc. tend to have such a bell-shaped curves. That means we have a data represents the heights of students. Suppose we want to know what is the distribution follows this data sets. Okay. So we plot the data using, or we may write the graph, the histogram of that data sets. Data sets includes observations are heights or weight. Okay, it is like the form of the normal curve. That is, it is a bell-shaped curve. Okay. A normal distribution is completely described as its central value or points of symmetry and spread around the center denoted by the standard deviations. So that is, this is the mathematical function of normal distribution. So this is the mean, mu, that is measure of center. This is the mean of this function, this random variable. So a random variable follows this function. So mean of this random variable is mu. That is measure of center, and the spread of this function, this random variable, is sigma square. That is the variance or standard deviation sigma. Okay. So normal distribution have two parameters. First one is mean mu. Second one is this variance sigma square. This is the measure of center. This is the measure of spread only. So that is, these mu and sigma are called the parameters of the normal distribution, and their roles in describing the center and the variability are illustrated in given figures. That is, this mu represents the center and sigma describing the variability. Okay. So this is the shape of the normal distribution. Normal distribution, that is the function, the graphical representation of this function. Graph of this function is simply this. Here, what is the meaning? Here, mu is the center. Okay, mu is the center. In the right part of the graph, that is equally distributed in left side as well as right side. That is, this is a symmetric distribution, symmetric about the mean mu. That is, normal distribution is symmetric about the mean mu. Okay. What is this means? That is, mu, in every data we have a mu. That means population mean. That is mean mu, and standard deviation sigma, and standard deviation sigma. So this is mu minus sigma. This is mu for every data. We are able to find out what is mean mu and standard deviation sigma. So in the case of this case, 68% of the observations lies between this range, that is mu minus sigma and mu plus sigma. Okay. So we have a numerical value mu minus sigma, and we have numerical value for mu plus sigma. So lies between this range, we have 68% of the observations. Similarly, lies between mu minus T sigma and mu plus T sigma, 95% observations are there. Okay. Similarly, 99.7% of observations are lies between mu minus 3 sigma and mu plus 3 sigma. Okay. That is, what is the meaning? 99.7% of the observations lies between this range, mu minus 3 sigma to mu plus 3 sigma. This is the, okay. Okay. Next, these are the different shapes. That is, mean mu tells us where the curve is centered. That is, what is the role of mu here? Mu tells us where the curve is centered. On the other hand, the parameter sigma is a measure of spread. Sigma is a measure of spread. That is, next point is smaller sigma. That is, sigma is very small. The taller and more concentrated the curve is at the center. That means if sigma is small, the curve is, that is, this is the curve for n02. This is n01. This is here, sigma is small, that is 1/2. In this case, curve is more concentrated, that is more concentrated at the center. This is the This is the peculiarities of some peculiar properties of normal distribution. Okay, the curve is symmetric and centered around the mean mu. Okay, although theoretically curve is lies between minus infinity and infinity, that is the range of the curve is actually minus infinity to infinity. We have already discussed this point, that is mu minus 3 sigma, mu plus 3 sigma contains 99.7% probability. Okay, this is actually called, considered as the practical range for the normal distribution. Okay, so mu minus sigma to mu plus sigma contains 68%. Mu minus t sigma to mu plus t sigma contains 95%. Mu minus 3 sigma, mu plus 3 sigma contains 99.7%. So these rules, the rules is sometimes called the 1 sigma, 2 sigma, 3 sigma rule, or 68, 95, 99.7 rule. This rule is also called the 1 sigma, 2 sigma, 3 sigma rule. Okay, this is just for theoretical interest only. Okay, in particular, this is the function of normal distribution, normal curve. If we substitute this mu is equal to 0 and sigma is equal to 1, mu equal to 0 and sigma is equal to 1. Mu is equal to 0 and sigma is equal to 1, we get another distribution related to normal distribution called the standard normal distribution. That is, the normal curve centered at mu is equal to 0 and sigma is equal to 1, called the standard normal distribution. Okay, because some practical problems are discussed based on this result. Okay, that is why I included this result here. That is, in the case of normal distribution, mu is equal to 0 and sigma is equal to 1, we get standard normal distribution. Okay. Next, what is central limit theorem? This is one important theorem. That is, in every statistical analysis, we need an assumption. That is the distribution assumption. That is, we find out our data follows which distribution. Our data follows which distribution. Okay. Okay. Central limit theorem roughly says that if the sample size, that is greater than 30, the distribution is approximately normally distributed. What is the meaning of this? That is, if we have a data is not that is observations are greater than 30, then the curve of that particular data sets approximately bell-shaped. Okay, that means sample size is large. That means maybe greater than 20 or 30. The curve of that particular data set is approximately bell-shaped. That is approximately normal distribution. Okay, that is, even if the sample is not from a normal distribution, that means we have a sample only. The distribution of x bar is, that is, the distribution is well approximated by the normal curve, provided the sample size is large. This is called the central limit theorem. So what is central limit theorem? CLT says that if the sample size is large, the data follows approximately normal distribution. That is, the corresponding curve of the corresponding data follows, the shape of the corresponding curve is approximately bell-shaped. Okay. An important question is how large should be n before we can use this normal approximation. So in every data analysis part, we have a normal assumption. We want a normal assumption. But we have a theorem, luckily we have a theorem known as central limit theorem. So in every sample size greater than 30, the data is approximately follows normal distribution. So we can use any statistical measures for further analysis. Okay. So one important question is how large should be n before we can use this normal? That is, what is the sample size n for this normal approximation? Unfortunately, there is no simple answer. It depends on number of factors. However, roughly we can say that sample of size 20 is desirable for this normal approximation. So what is the conclusion here? If we have a data with 20 or more observations, it's a shape of the curve of that data set is approximately well shaped, that is approximately normal. So we don't go for further distributional assumptions. Okay, this is enough for further statistical analysis. Okay, this is in the curve of standard norm. Okay, so these are some basic necessities for defining, so for discussing what is in the statistical inference. For discussing what is statistical inference. Okay, so what is statistical inference? Before going to the concept statistical inference, first we want to know what is parameter. Parameter. In every, in every statistical study, we have a population. Also, we have a sample. Okay, in population, we are able to find some population mean mu, population variance sigma square, population standard deviation sigma. That is, in every population, we may able to find population mean, population variance, population standard deviation. Population mean is simply denoted by mu. Population variance is denoted by sigma square. Population standard deviation is denoted by sigma. These are called the parameters. This is simply known as parameters. Simply known as parameters. So what is statistic? We have a population. We want to take a sample. So we have a sample. Based on samples, we have some measures. That is sample mean, sample variance, and sample standard deviation. This is simply known as statistics. So population mean, in every statistical study, we have a population and we have a sample. So population characteristics are known as parameters. Corresponding sample characteristics are known as statistic. Statistic. Not statistics, but statistic. Okay. Okay. Please note these notations. Population mean is mu, population variance is sigma square, population standard deviation sigma. Similarly, statistic sample mean x bar, sample variance square, sample standard deviation sigma. So, what is the statistical inference? Statistical inference. Statistical inference is concerned with making decisions regarding the unknown aspects of the distribution of the population based on samples taken from it. These unknown aspects may be the form of the distribution or the values of the parameters or both. That is what is statistical inference. So statistical inference is the process of making inferences. Actually, it is the process of making inferences based on samples taken from the given population. So statistical inference is the process of making inferences based on samples taken from the given population. This is simply statistical inference. Actually, process of making inferences based on samples taken from the given population. For example, suppose we want to study the number of smokers in a particular district. So, you know, in this case, the population, the study based on complete population is impossible. So only possibility is the sample study. So we take some samples, and based on samples, we reach a decision regarding population. Based on samples, we reach a decision regarding population. This is actually statistical inference. Actually, this is done in statistics. Okay, so statistical inference is a process of making inferences based on samples taken from the given population. This is classified into two. Statistical inference is classified into two categories. First one is estimation of parameters. Second one is to estimate the parameters. Second one is to test the hypothesis about these unknown parameters using sample data. That is, you know what is statistical inference? Statistical inference is again classified into two. First one is estimation of parameters. Estimation of parameters means, for example, in the case of normal distribution, we already told that the population characteristics are parameters. In the case of normal distribution, mu and sigma square are parameters. Similarly, in the case of binomial distribution, this n and p are parameters. N and p are parameters. So, the first thing in the statistical inference is estimation of parameters. That is to estimate the parameter of a particular distribution. Second one is to test the hypothesis about these unknown parameters using a sample data. That is, we are roughly says that average weight of a students in a particular class is 70 kilogram. So this is a statement. So we want to test this statement. Okay. So another important area of statistical inference is based on the available sample information, test the statements, hypothesis. Okay. Okay. Okay, so thus far we have been seen describing how the number of success follows a binomial distribution and how variables like heights or scores or their means follows normal curve. This is actually done. We have assumed that this time what we knew the so-called parameters, the true proportion or probability P in a binomial distribution or mu and sigma for a normal curve. That is, what is the parameters? We have discussed two distributions. One is binomial distribution, other one is the normal distribution. In the case of binomial distribution, probability P is the parameter. P is the parameter. In the case of normal distribution, mu and sigma is the parameters. However, in practice, these parameters are typically not because parameters are population characteristics. These characteristics are technically unknown in reality. Okay. Parameters are actually population characteristics. These characteristics are unknown because these parameters are the population characteristics. Okay. So what is the possibility for estimating these parameters? That is, suppose I already told that we want to know what is the average number of smokers in a particular district. So in this case, population study is impossible. So in this case, based on samples, we estimate the number of smokers in a particular city. So So this is called the estimation of parameters. Estimation of parameters. So estimation of parameters is again two types. First one is point estimates. Point estimates. That is, point estimates are estimates since they give a single value or point as an estimate of the corresponding unknown quantity. That is, because we don't know the value of the number of smokers in the population, but we have the value of the number of smokers in the sample. So this number is the number based on sample is the estimate of the population. Estimate of the population. Okay. Similarly, in the case of normal distribution, mu is the population mean and sigma square is the population variance. Here we suggested sample mean x bar is the estimate of population mean mu, and the sample variance S square is suggested as the estimate of population variance. So sample mean is suggested as the estimate of population mean, and the sample variance is suggested as the estimate of population variance. This is the way of proposing estimators. This is some just example. Okay, so next problem is what is confidence interval for mean with non-sigma? That is estimation. Statistical inference is mainly concerned in two groups. That is estimation of parameters. Second one is testing of a hypothesis. Estimation of parameters is again classified into two categories. First one is point estimation. That is suggest a point value for the population parameter. It is called a point estimator. But in some cases, we have an interval. We have an interval. That is average marks of a particular class lies between this and this. So in this case, we have an interval. So this is the actually interval estimator. This is actually the interval estimator. I hope the ideas are clear because this is the basics of statistical inference. First one is estimation of parameters. Second one is testing of hypothesis. Estimation of parameters is again classified into two: point estimation and interval estimation. Second one is testing of hypothesis. For example, this is the formula for finding interval estimate of population mean mu. This is the formula. That is, we have 68, 95, 99.7 rule from standard normal curve. This is from this idea. We have a formula for population, formula for obtaining the interval estimate for the population mean mu. So this is the formula. This is actually this is the interval, that is x bar minus 1.96 into sigma by root comma x bar plus 1.96 into sigma by root is this is the lower limit. This is the upper limit. This is the formula for finding interval estimate of population mean mu when sigma is known. This is also known as confidence interval for estimating mu of the population when sigma is known. Okay, so this is the formula. I have given one example, that is, suppose x, the score of a test on a numerical ability, have a normal distribution with the unknown mean mu and known sigma. That is, here x is a random variable. It represented by the numerical ability with the mean mu unknown, but sigma known. Suppose the sample values 900 samples are taken. Give sample mean 217. Find 95% confidence interval for the true mean mu. Actually, the question says that x follows no x is a normal distribution represented by the numerical ability. If the mean mu is unknown, sigma is given. Find an interval estimator of this mean mu. Okay, so in usual case, we have suggested sample mean as the estimator of the population mean. That is simply point estimator. Here we want to find the interval estimator. Here, what is point estimator? Point estimator is 272. Point estimator is 270 because we want the estimate of mu, that is population mean mu. Given that sample mean is 272, so we suggested 272 is the okay. 272 is the point estimator of that population mean mu. Okay. But in interval estimator, we have a formula that is x bar minus 1.96 by sigma by root n, x bar plus 1.96 by into sigma by root n. So computing this interval, we have the value 268.08 to 75.92. So what is the meaning of this? What is the meaning of this? Or this that is here. The numerical ability have a normal distribution with unknown mean mu. The value of this mean mu is estimated based on samples and its value is 272. This is the point estimator. In interval estimator, this interval says that the value of this mu lies between 268 and 275. So in point estimation, we have a particular value. But in interval estimation, we have an interval. That is, mu actually lies between this interval. I hope the idea is clear. Okay. Next, next discussion is what? Choice of sample space. That is, we produce a reasonable estimator. What is the required sample size? What is the required sample size? That is, what is the minimum sample size for producing a reasonable estimator? This is an important problem. So, in the case of statistical analysis, one confusion is how many samples are required for effective effective estimates, for producing effective estimates. How many samples are required? There are so many formulas available. Here I discuss only one formula that is based on theoretical formula. In every softwares, you have different options for computing the value of n. Simply, what is the idea? What is the minimum sample size required for estimating, required for producing an estimate? Okay. Here, what is the margin of error or half width of confidence interval? That is given by Z alpha by 2 sigma by root n. It is actually obtained by the formula for confidence interval. Okay. The confidence sample size n is given, sigma is given. Sample size in that we have a sample size, we have sigma, and the confidence level is Z alpha by 2. That is, this is obtained from the table. So the n may be calculated. Sample size, sample size n is not given. Okay, sample size is given. In this case, we have this formula. N is equal to Z square alpha by 2 sigma square by m square is the sample size required for the margin error to be m. So this is the sample size. Actually, sample size is not given. We take sample size is n, and the population standard deviation is sigma, and the confidence level is z alpha by 2. So in this case, for a given margin of error m also, n is, this is the formula for finding. This is the formula for finding n. An example is given. Suppose etc. The observations follows normal distribution with the sigma given. In a sample size is 16. We observe x bar is 16. That is the point estimator of mu. Find 95% confidence interval for mu. Find the n needed in order that the margin of error n is equal to 3 inches. Okay. So our problem is that data is height, that is from n mu sigma means this data as follows normal distribution. Simply we can say that the graph of the data is in symmetric shape. Through histogram we may observe. Okay. Also population standard deviation is given. Okay, find 95% confidence interval for mu. That is, we may interested to find the confidence interval. That is interval estimator for mu. Interval estimator for mu. Actually, point estimate is 60. So using the above formula, x bar plus or minus z alpha by 2 sigma by root. That means x bar minus z alpha by 2 sigma by root, comma x bar plus z alpha by 2 sigma by root. So we may obtain this interval, that is 55.1 and 64.9. That is the value of the mu lies between this interval. Value of mu lies between this interval. Similarly, point estimate is 60, but the interval estimate is 50. Interval estimate, that is mu lies between 55.1 and 64.9. So we are given the values of z alpha by 2, sigma, and margin of error to m equal to 3. M equal to 3. That is, so n is equal to 42.68, which is round up to 43. That thus, if we increase the sample size to 43, instead of the original 16, we can reduce the margin of error from 4.9 to inches to 3 inches. This is the inference what we get here. What we got here, that is, which is round up to 4. That is, if we increase the sample size to 43, instead of original 16, we can reduce the margin of error from 4.9 inches to 3 inches. Okay, so first part of the statistical inference is estimation of parameters. Most of the ideas are based on theoretical. I think this idea will wind up here. Next concept is testing of hypothesis. This is more closely related to your statistical analysis. That is what we mean by testing of hypothesis. Okay, testing of hypothesis. So in statistical inference, we have two problems. First one is estimation of parameters. That means simply estimate the value of the parameter of the population, which may classify into two groups: estimation of point estimation, second one is interval estimation. Next problem is what is testing of hypothesis. For that, first we consider what do you mean by hypothesis? What do you mean by hypothesis? I think these some of them are already know these ideas. That is what you mean by hypothesis. You may know what is research hypothesis, what is statistical hypothesis, etc. So what is hypothesis? Any statement is called a hypothesis. Simply, we can say that any statement is called hypothesis. For example, there are 12 months in a year. This is a hypothesis. Sun rises in the east. This is another hypothesis. It will be raining in the evening. It is another hypothesis. I will get first class on the examination. It is another hypothesis. Okay. So what is the speciality of these hypotheses? You know, this is a sure hypothesis. Simply a statement is called a hypothesis. This is a sure statement. That is, there are 12 months in a year. It is very clear. There is no need for testing or verifying this hypothesis further. This is also natural truth. This is also natural truth. There is no uncertainty. No uncertainty. That means there is no need for verifying or testing the first two hypotheses. These two statements are sure statements. But when we look into the third statement, it will be raining in the evening. We are not sure. That means some uncertainty is here. Next is, I will get first class on the examination. That is, there is some uncertainty. So, what is the difference? These two statements are sure statements. There is no need for testing or verifying these statements. These two statements are contains some uncertainty. That is, we are not sure. So we are forced to define what is statistical hypothesis. What is statistical hypothesis? So what is statistical hypothesis? An assumption concerning the form of the distribution or the value of the parameters of a statistical population is called a statistical hypothesis. Average weight, like average heights of a particular group of population is 180 centimeter. Average height of a particular population is particular group is 180 centimeter. So this is the statistical hypothesis. Here the hypothesis is given in the form of the parameter of statistical distribution. Here, hypothesis concerning the form of the parameter of a statistical distribution. That is simply here given population is mu. Mu is equal to 190 centimeter. So we want to verify or test the validity of this hypothesis. I hope this differentiation is clear, because what is hypothesis and what is the statistical hypothesis. So what is statistical hypothesis? Statistics, the hypothesis simply the hypothesis of the concerning the form of the distribution or the value of the parameter of statistical population. So next we define what is null hypothesis. What is null hypothesis? The hypothesis which is to be tested. That is, what is the tested hypothesis? In another way, it is denoted by this H naught. Null hypothesis is denoted by H naught. It's a statement denoting no effect, no change, or status. That is the hypothesis. That is as in the null hypothesis. Sorry, statement as in the name of the hypothesis. That is null hypothesis. The hypothesis which is to be tested, or a statement denoting no effect, no change, etc., is called a null hypothesis. The hypothesis alternative to the null hypothesis is called alternative hypothesis. So that is also known as research hypothesis. So in every research problem, we have a hypothesis, that is a null hypothesis. The hypothesis alternative to the null hypothesis is what is called the alternative hypothesis or research hypothesis. Alternative hypothesis or research hypothesis. So what is the procedure here? So we may take the decisions based on samples whether null hypothesis is accept or not. Null hypothesis is accept or not. Okay. So in hypothesis testing context, we take the attitude that we will hold on the null hypothesis as a true and reject it only if there is a sufficient evidence against it. Much the same attitude as expressed in statements like innocent until proven guilty, or conservative philosophy, do not fix things if they are not broken. That is what is the meaning? We are on the position that null hypothesis is true until there is a sufficient evidence against the null hypothesis. Okay, that is, we may prove the null hypothesis using the available information on samples. Available information on samples. So, in coin dosing experiment, a coin is dosed 100 times. Give 62 heads. Is the coin is fair? So our problem is a coin is dosed 100 times. 62 heads are occur. We want to check whether the coin is fair. So what is the null hypothesis here? Null hypothesis is always denoted by H naught. Alternative hypothesis is always denoted by HA. So null hypothesis is denoted by H naught. Alternative hypothesis is denoted by HA. So how in this problem, how you can set the null and alternative hypothesis? If the coin is fair means we want to check whether the coin is fair or not. That is, we may set in the null hypothesis as H naught such that P is equal to 1/2. That is no change. That is, the coin is fair. So this is the null hypothesis here. That is, we may assume that the coin is fair. That is, head occur with the probability 1/2. A coin is fair means equal probability for getting each face. Okay, so this is the null hypothesis here. The alternative hypothesis is the coin is not fair. Not fair means there is a difference in the probability. There is a difference in the probability. This is the one alternative hypothesis. So P is equal to 1/2 is the null hypothesis. P not equal to 1/2 is the alternative hypothesis. Okay, there may be another alternatives also. That is, maybe null hypothesis is this only. Alternative hypothesis may be P greater than 1 by 2 or P less than 1 by 2. So we have a null hypothesis. Against this null hypothesis, we have three alternatives. Maybe not equal, maybe greater than 1 by 2, maybe less than 1 by 2. Okay, this is called, such an alternative is called a two-sided alternative, because if the alternative hypothesis is in this form, that is P not equal, this is called a two-sided alternative. If the alternative hypothesis is either in this form or in this form, it's known as one-sided alternative. Okay. This is the way of setting the hypothesis. So in every research problem, we must have hypothesis. Next example. Suppose there are two treatments or drugs or treatment and a control that we wish to compare. That is, we want to compare two treatments. Often we need to test if one treatment or drug is better than the other. State the null hypothesis and alternative hypothesis. So our research problem is we have two treatments or drugs. We want to compare these two treatments whether a particular treatment is more effective. Okay. So solution is H0. What is H0? There is no change. That means two drugs are equally effective. As in the case of H0 such that P is equal to 1 by 2. So two drugs are equally effective. Versus the two-sided alternative. Here, what is the two-sided alternative? The effects of the two drugs are different. Okay. So our null hypothesis is two drugs are equally effective. Our alternative hypothesis is the effects of the two drugs are different. Or alternative, drug 1 is better than drug 2. Or another alternative, drug 1 is worse than drug 2. So this is the way of setting the null and alternative hypothesis. Okay. That is, H0 means the two drugs are equally effective. Alternative hypothesis means the two drugs are different, effective of two drugs are different, or drug 1 is better than drug 2, or drug 2 is better than drug 1. This is the way of setting the hypothesis. Next, an important thing is in every statistical analysis, we have conducted the statistical analysis based on samples. So there is a chance for accepting a false hypothesis. Also, there is a chance for rejecting a true hypothesis. Okay. In every statistical testing problem, statistical analysis is conducted on the basis of available samples. So there is a chance for occurring error. That means sometimes true hypothesis may be rejected and false hypothesis may be accepted. So in this case, there occur some errors. That is, first one is rejecting H0 when it is true. That means actually our null hypothesis is true, but unfortunately it is rejected. So there is an error. It is called type first error. It's called a type first error. Similarly, H0, that is actually H0 is false. Unfortunately, we accept H0. So there is an error also, that is type second error. So there is in every statistical hypothesis, there is a chance for occurring an error. So in this case, so in statistical testing procedure, first we fix the type first probability of occurring type first error. That is probability of type. We may fix the value of the probability of type first error is equal to alpha, significance level alpha. Usually it takes value 0.05 or 0.01 and try to minimize type second error. That is, in any testing problem, there is a chance for occurring an error. In this case, we actually do we fix the null hypothesis. Sorry, probability of occurring type first error is a prefixed level alpha. This is called a significance level. Significance level. Also, we have another term, power of the test, that is denoted by beta. This is 1 minus probability of type second error. 1 minus probability of type second error. Okay. So in every, if we perform the statistical analysis using some software, we have a p-value. We have a p-value. So the analysis or the conclusion is, if we do the analysis in statistical analysis using some software, the conclusion is based on p-value only. So what is the p-value? What is the relation connecting p-value and this significance level alpha? P-value and this significance level alpha. Okay. A p-value is nothing but the probability value. That is, all hypothesis tests ultimately use a p-value to weigh the strength of the evidence, what the data are telling you about the population. Okay. The p-value is defined as the smallest value of alpha for which the null hypothesis can be rejected. So this is the p-value. That is the smallest value of alpha. Alpha, you know, alpha is the probability of type first error. So p-value is the smallest value of alpha for which null hypothesis can be rejected. So how can I conclude the based on p-value? That is, if p-value is less than or equal to alpha, in a statistical analysis, p-value is less than alpha, we reject the null hypothesis. Otherwise, accept the null hypothesis. So if the p-value is less than the significance level, that is very small p-value, we reject the null hypothesis, otherwise accept the null hypothesis. Okay, I hope the idea is clear. Okay, next problem is, we have already said that we have a large sample test and we have small sample test. Okay. We have already said that we have two tests, that is a large sample test and a small sample test. Large sample test means sample size approximately roughly sample size is greater than 30. Similarly, small sample test is less than 30. Sample size is less than 30. So consider a problem that is here. Consider a problem that is a factory was producing electric bulbs of average life of 2000 hours. That is, a factory was producing electric bulbs which have average life 2000 hours. A new process was introduced with the hope that the length of life of the bulbs will increase. That means after a new process introduced, and expect that the length of the bulbs will increase. So we may check a sample of 50 bulbs produced by the new process and was found to have an average lifetime 2,200 hours with standard deviation 300. Examine whether it is reasonable to think that the length of the life of the bulbs would increase. So what is the problem here? We have an electric bulbs of average life in 2,000 hours. A new process was introduced with the hope that the length of the lives bulbs would increase. A sample of 50 bulbs produced by the new process was taken and found to have an average life of 2,200 hours and standard deviation 300. Examine whether it is reasonable to think that the length of the life of the bulbs has increased. Okay. I think the question is clear. Here, in this case, such a type, here actually the problem is testing problem of mean of the population, testing the mean of the population. So in this case, the formula is this, that is, consider the testing H0 such that mu equal to mu 0. Mu equal to mu 0. That is, population mean mu is equal to a particular number. When sigma is known, we have a formula Z is equal to x bar minus mu naught by sigma by root. This follows in standard normal distribution. That is, actually statistically this is known as test statistic. Okay, so if we have the testing problem mean of the population, this is the formula. Okay, so this is the testing problem of testing the mean of the population. So what is the problem here? What is the null hypothesis here? What is the null hypothesis here? Here H0 such that mu equal to 2000, that is 2000 hours. Our alternative is new. After introducing new process, whether we want to check whether the performance of the bulbs increase. So here examine whether the length of the bulbs would increase. Would increase means it is greater than 2000. This is the alternative hypothesis. So a null hypothesis and the alternative hypothesis. Actually, this is the research hypothesis formulated based on the given data. Null hypothesis and the alternative hypothesis is formulated based on the given data. Also, we have given sample size 50. So sample mean 2200. Sample standard deviation 300. These data are also given in the problem. Okay, so here the sample is 50. So we know that this is a large sample test. This is a large sample test. Okay, so under H0, what is our formula? X bar minus mu 0 by sigma by root. But here sigma is not given. Here sigma is not given. Instead, S is given. Sigma is not given, but S is given. So no problem. If sample size is large and sigma is not known, it can be replaced by S, no problem. Okay, that is, sample size is 50. Sigma is not known, it can be replaced by S only. So calculate Z is equal to 4.71. This is a manual calculation. Z is equal to 4.7. This is actually calculated value. This is the calculated value. Okay, so the conclusion is based on the table value also. In the manual calculation, the conclusion is based on the corresponding table value. That is, if in this problem alpha is not given, if alpha means probability of type first error, if alpha is not given, it may take 0.05 or 0.01, like that. Here, in the case of alpha 0.05, mu greater than mu 0. Alternative, this is the alternative. Table value is 1.65. Table value is 1.65. If alpha is this is the alternative. Table value is minus 1.65. If alpha is this, alternative is this, table value is 1.96. So in this case, our alternative is greater than 2000. So table value is 1.65. 1.65. So here calculated value, this value, calculated value is greater than this value. Calculated value is greater than this value. So the procedure is reject the null hypothesis. Here, calculated value is greater than table value. So we reject the null hypothesis. Calculated value is greater than table value means reject the null hypothesis at 5% level of significance. That is what is the meaning? We reject this hypothesis and accept this hypothesis. So what is the meaning? What is the meaning? After introducing a new process, the life length of the bulbs would increase. Life length of the bulbs would increase. But the conclusion is at 5% level of significance. In every statistical conclusion, we must say that what is the level of significance. So what is the meaning? That is 5% this result may be failed. Okay, so what is the conclusion? After introducing new process, the life length of the bulb will increase. So here accept the alternative hypothesis. Okay, so this is the graphical representation of numerical value. Next another example is given. A sample of 400 observations were taken from a population with standard deviation 15. If the mean of the sample is 27, test whether the hypothesis that the mean of the population is less than 24. Okay, so here what is our problem? What is the research problem? What is the hypothesis? A 400 observations are taken from the standard deviation 15. Mean of the sample is 27. Test whether the mean of the population is 24, less than 24. So what is the null hypothesis? There is no change. That is, mean is equal to 24. Alternative is mu less than 24. Also given that n 400, x bar 27, s is equal to 15. S is equal to 15. Okay, here alternative is lesser. So in this case, h naught. Z is sorry under h naught. This is the formula. Z is equal to 4. Z is equal to 4. So also here the alternative hypothesis, the value of the alternative hypothesis is less symbol of alternative hypothesis, that is mu less than 24. So here the calculate table value is minus 1.65, minus 1.65, and alpha is equal to 0.05. So in this case, alpha 0.05 table value, that is, we may take z alpha dash is equal to minus z alpha. This is actually minus of 1.65. Here the conclusion is in this form. If z less than z alpha dash, that is z is less than z alpha dash, implies reject the null hypothesis. But here z is actually greater than z alpha dash. Here the procedure of conclusion is this. This is the criteria for conclusion. This is the criteria for conclusion. But here, this is greater. So we accept the null hypothesis. 5% error. So first problem, alternative is greater than. In this case, conclusion is this way. Second problem, alternative is lesser. Conclusion is this way. Third problem, a sample of 100 students is taken with the heights and standard deviation of 10 centimeters. The mean height of the sample was found to be 168.8 centimeters. Can we accept the assumption that the mean height of the students is 170 centimeters? Okay, here the question is, can we accept the assumption that the mean height of the students is 170? Can we accept? So our H0 is, there is no change, mu is equal to 170. Alternative is mu not equal to 170. That is simply says that, can we accept? There is no indication of greater than or lesser. So here we take alternative is not equal. Okay. Also given that value of x bar and s. Okay. I already says that n is equal to large n. Instead of s sigma, we can replace sigma by s. So here also z is equal to 1.2. Okay, in the normal case, if alpha is equal to 0.05 and alternative is not equal, table value is 1.96. Table value is 1.96. So in this case, table value is not this. This is a mistake. Actually, table value is z alpha by 2. Z alpha by 2 is 1.96. Okay. Also, this is the conclusion. If the alternative is not equal, we always consider the calculated value as modulus of z. That is, if the alternative is not equal, we always consider the absolute value of the calculated value, mod z value, and the table value is alpha by 2. Here, calculated value, this is less than 1.96. That is, calculated value is less than table value. We accept the null hypothesis at 5% error. So what is the meaning? Here, dv is equal to 170 only. Okay, I think some questions are there.
Sir, shall I read out the questions for you?
Okay, yes. After that, I will continue.
Okay, sir. The first question is from Rajan Parikh. He asked, can I ask one question relates to HO?
Sir, can I ask one question relates to H0? This is the question.
Yes, sir.
Okay, I think. Okay, I will answer this question based on this question. So, H0 means always what is the tested hypothesis? What is the basic hypothesis? Is H0. That is, in this case, we want to test the average life of bulbs of the lifetime of the bulbs is 2000 hours. So in this case, H0 is mu equal to 2000. H0 is our null hypothesis. What is the tested hypothesis? Okay. Similarly, in this case, what is H0? Here we want to test mu is equal to 24. So this is H0. Next question is in this question, what is the H0? H0 is the null hypothesis. Mu is equal to 170. So in general, H0 means there is no change. That is in neutral sense. Okay. I hope the answer is clear. Okay. Next question.
So next question is from Praveen Krishnan. What is directional hypothesis?
What is?
Directional hypothesis.
What is directional?
Yes, sir.
Okay. I think he is asking again null hypothesis. There is no directional, statistically there is no directional hypothesis. We have only two hypotheses, null hypothesis and alternative hypothesis. Okay. In statistics, we have, in testing problem, we have two hypotheses only. First one is null hypothesis, second one is alternative hypothesis. There is no directional hypothesis. Okay. Null hypothesis, I already told that null hypothesis is the tested hypothesis. The hypothesis alternative to the null hypothesis is alternative hypothesis. There is no directional hypothesis. Okay. Okay. Next question.
Okay, sir. Next question is from Anushri. So what is the correct explanation of normally choosing significant level at 1 or 5%?
I already explained in this concept that is in testing problem, there is a chance for occurring two types of errors, that is type first error and type second error. So in all testing problem, we may fix the level of type first error. The probability of occurring the level of type first error is equal to alpha. Usually this may take, that means alpha means in every testing problem, we conclude that the result, we conclude the results at some level of significance. Usually it is the 5% or
hello.
Yeah. Practical considerations only.
Yes.
Okay.
Yes. Sir, I want to ask one question actually. Yeah, sir. I am doing research for India VIX volatility index with sectoral index like bank index, auto index, and all.
I think your voice is not clear.
Yeah, just a minute, sir. Am I audible now?
Yes.
Sir, I am doing research for volatility index, and I am comparing it with other sectoral index like bank index, auto index, pharma index, like that. So one hypothesis I have taken, let's say as 0, like there is no relationship between volatility index and selected Nifty index. But selected Nifty index are total 4, what I have taken. So can I take H0 combinedly for all of them, or I need to take them separately for each indexes actually?
Actually, I think your testing problem is we have another, that is comparison of two more samples. Here we consider the problem for testing the mean of the population is a particular number. So I think your research problem is H0 such that mu1 is equal to mu2 is equal to etc. is equal to mu k. And alternative hypothesis is H1 such that mu1 not equal to mu2 not equal to etc. mu k. Okay.
Okay, sir. So I need to take all of them separately, even for regression analysis also.
No, you may go for, I think if your testing problem is a comparison of several means, you may simply go for the concept analysis of variance, ANOVA.
Okay.
Okay.
Right.
Okay. Here I consider the testing problem for the mean of a normal population only. So mean is a particular number. We have the extended version of this problem. Okay.
Right, sir. Okay, okay, fine.
Okay, okay.
Okay, sir.
Okay. So next question.
So there is one more question from Praveen. So please explain level of significance and degrees of freedom.
Level of significance means simply significance level. That is level of significance is defined as, that is alpha is defined as probability of type first error. That is the probability of type first error is simply known as level of significance or significance level. Degrees of freedom means what is how many variables are independently moved. That is, suppose we have n observations, n minus 1 variables are independent. So this is actually degrees of freedom. Level of significance is simply size of the test, or alpha is equal to probability of type first error. Okay. Okay.
Okay, sir. So participants, if you have any doubts or questions, you can either raise your hands, unmute and ask, or drop your question in the chat box. Over to you, sir.
Okay. 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 Next problem is, so I have discussed what is the testing the mean of the normal population. Is a mean of the population is a particular value. Mean mu is a particular number. There is we have another test for the mean of a population, that is simply t-test. T-test. Actually, if we have a t-test is also to test the mean of the population, then sigma is not known. So t-test is used for testing the mean of a population when sigma is not known. When sigma is not known and sample size is less than 30 or less than 20. That is, if the sample size is small and sigma is not known, in this case we go for t-test for testing the mean of the population. Okay, so actually what is t-test? T-test is actually used for testing the mean of the normal population when sigma is not known and sample size is less than 30. In this case, the formula is simply same formula. D is equal to x bar minus mu 0 by s by root n, s by root n. But the problem is here this t follows this statistic. This follows t distribution with n minus 1 degrees of freedom. So what is the meaning? In this case, table values obtained from t table only. That is from t distribution table. Okay. So this is the t-test. So actually what is what are the assumptions here? Sigma is not known, that is population standard deviation is not known, and sample size is less than 30. Sample size is less than 30. So in this case, the formula, that is test statistics, is x bar minus mu 0 by s by root n, which follows student's t distribution with n minus 1 degrees of freedom. So what is the problem here? So this is the idea for concluding based on conclusion based on t-test. So first you calculate t is equal to x bar minus mu 0 by s by root n. That is the formula. Secondly, if the alternative hypothesis is Secondly, you may calculate T alpha or T alpha by 2. T alpha means stable value in the case of one-sided alternative. T alpha by 2 is the stable value in the case of this alternative. Secondly, you calculate these values. In third step, if the alternative is this form, reject H naught if T less than T greater than T alpha. Alternative is less than this, reject H naught if T less than minus T alpha. Alternative is this, reject H naught if modulus of T greater than T alpha by 2. This is as in the case of normal test or Z test. This is similar to the case of normal test or Z test. Okay. So problem, suppose a sample of size n is equal to 16, result in sample mean x bar 64, sample variance 25. To test mu equal to 66 against alternative mu less than 66. Here alpha is taken as 0.05. So here hypotheses are given. I have just taken for explanation. Hypotheses are given mu equal to 66 against this. Here t is equal to this. So the value of t is equal to minus 2.4. Minus 2.4. Okay. From t table with the n minus 1 degrees of freedom. That is from t table. You can from t table we have in every chi-square distribution, t distribution, f distribution, we have a statistical table. We have a statistical table. From statistical table, you can easily find out alpha is equal to 0.05 and n minus 1 degrees of freedom. Table value is 1.69. 1.69. So this is the criteria for conclusion. T less than minus T alpha means reject H naught. Here minus 2.5 is less than minus 1.69. So we reject H naught at 5% level of significance. Okay, that means 5% this result is wrong. There is a chance for 5% chance for wrong in this result. Okay, so this is the conclusion. Similarly, in the next problem, n is equal to 36. Actually, just for explanation, we take this data. N is equal to 36. We get mean 10 and standard deviation 3.2. To test mu is equal to 8 against mu greater than 8. Here also alpha is 0.05. Maybe alpha is taken as 0.01, 0.02. All the values are available in the table. Usually we take alpha is equal to 0.05 is just for practical consideration. Okay. Here t is equal to x bar minus mu 0 by s square root n. So we calculate the value of t is equal to 2.5. Here also mu greater than mu 0, that is 8, n minus 1 and alpha 0.05. This is the table value. So this value is greater than this. So we reject H naught at 5% level of significance. Okay, this is the conclusion criteria. Next is what is a paired t-test. I'm sorry, t-test, the assumptions of t-test are to test. T-test is used for testing the mean of the population, and sample when sigma is not known and the sample size is less than 30. This is the basic assumption for t-test. Okay. Okay, suppose in a bivariate data, suppose an example is given. X be the score on a test for an individual before he undergoes a certain training, and Y be the scores of the same individual after such training. So we have a pair of observation, or XY could be the heights of twins or siblings. in such cases, the dependence assumption about X and Y is not valid. That means we have a pair of observation. That is, these are connected observations. In this case, actually, the observations are connected. In this case, it is easy to see that the problem of testing equality of means can be translated into which says that the difference between X and Y have means 0. Okay. In this case, let mu X be the mean of X observations and mu Y be the mean of Y observations. We wish to test the null hypothesis that this is equal to this. Mu X equal to mu Y and sorry, H not T equal to H not such that mu X equal to mu Y against alternative HCA such that mu X less than mu Y. That is, here we want to check after training. There is an effect. Okay. So this is the testing problem here. So we have X observations before training and Y observations after training. So we want to test the effect of this training is effective. Okay. So this is actually done in the paired T test. Okay. The procedure is, so we have in this case, we have a pair of the observations. Let D stands for the difference X minus Y. So we have X observations, we have Y observations, D be the difference of X observations and Y observations. Then it is easy to see that mean of the difference mu D is equal to 1. Okay. So we get the different D observations. Okay, so mu D is the mean of the difference mu D is equal to the difference in the means. Okay, so mu D denote the difference of means. That is difference of observations D observations mean of the D observations. In this case, this is rearranged into. That is, this testing problem is same as mu D equal to 0. That is, mean of the difference is 0 against mu D, mean of the difference is less than 0. That is, in this case, hypothesis formulated in this way. Okay, this is equivalent to this. So I have given one example. In this case, test statistic T value T is equal to D bar by, that is, in this case, formula is D bar by N. That is, D bar is the mean of the D observations and SD square is the standard deviation of the observations differences. Okay. So for illustration, I have given an example. That is the amount of lactic acid in the blood was examined for 10 minutes before and after strenuous exercise with the following results. So this is the before exercise, this is the data. After exercise, this is the data. After exercise, this is the data. Thus, if exercising changes the level of lactic acid in the blood, that is to check whether there is any effect in the exercise. Okay, this is the testing problem. So here alpha is equal to 0.005. So in this case, first you find the differences. D is equal to after level minus before level. So this is the D values, that is 33 minus 15, 18, 20 minus 16, 4, 30 minus 13, 17, 35 minus 13, etc. So this is the differences. So here we want, what is the testing problem here? We want to test mu D equal to 0. That is, difference, mean of the differences is equal to 0 against mean of the differences is not equal to 0. Mean of the differences is equal to 0. Mean of the differences is not equal to 0. Mean of the differences is not equal to 0. So this is the testing problem. So we want to find d bar. D bar is equal to 1 by n sigma is equal to 28. That is sum of these observations by n. We get 12.4. This is the mean. Actually, also the standard deviation, that is variance of the observation, not a standard deviation, variance. Variance of the observation is this 63 points. Okay, so this is not a D, this is T. It's a mistake. So here the value is T is equal to 4.9342. So this is the value for this statistic T. Okay, as usual, we have 10 observations. This is 9 minus 1 is over here, degrees of freedom. That is 9 minus 1 observations are independently moved, one independently varying, and alpha is equal to 0.005. In this case, T alpha, this value is obtained from the paired T table. Okay, here T value, that is T, this is T value. This is greater than T alpha by 2. This is greater than T alpha by 2. We reject H0 at 5% level of significance. We reject H0 at 5% level of significance. That is what is the mean. There is some differences. This is we rejected. This is equal to 0. That means mu d equal to 0 means there is no differences. The statement like there is no differences is 0 is rejected. That means there is some differences. That is exercising change the level of lactic acid. And level of lactic acid is the conclusion of this problem. So this is the situation for using paired t-test. This is the situation for using paired t-test. Let's discuss one more problem. So far, we have discussed what is the testing problem concerning the mean of the population. Similarly, we may discuss. We test the standard deviation of the population. We may discuss. We may test the standard deviation of the population. Standard deviation of the population. That is, this is the standard deviation. That is standard deviation is a particular number. This is in this case. This is the hypothesis. Okay. So here the formula is chi-square. Here the formula is chi-square. You know chi-square. Chi-square is equal to, this is the formula. So in this case, we calculated the table value from chi-square distribution table. Because this follows chi-square distribution. Okay. So first case we go for normal table. We have some fixed values, table values. Secondly, in the t-test and the paired t-test, we go for t-table, in statistical table. In the case of sigma testing problem, testing on sigma, we go for chi-square table. As usual, this is the procedure of conclusion. So this is one problem. A scientist who is studying the brain waves of tigers took a random sample of 16 animals and measured their brain weights in ounce. Suppose this data gave a standard deviation 3.2. Test the hypothesis that H0 4.2 versus the alternative sigma 4.2 equals to alpha is equal to 0.05. That is, here simply instead of testing mean of the population, here test the standard deviation of the population. That is, standard deviation of the population is actually we want to test H naught, standard deviation is 4.2, against it is 4. Sigma and standard deviation is less than 4.2. Here, this is the formula, n is given, s square is given, sigma naught square is given. So this is the calculated value, 8.71. Okay, this is the calculated value. From chi-square distribution with the n minus 1 degrees of freedom, that is the criteria for obtaining a table value from chi-square table, and alpha is equal to 0.5. This is the table value. This is the 7.26 is the table value. So calculated value, this is greater than table value. Calculated value of chi-square is greater than table value. We may reject the null hypothesis at 5% level of significance. That is, we may reject H naught such that sigma is equal to 4.2. Okay, this is actually testing problem of standard deviation testing. So in the testing the mean of the population, we use normal test or result test. Testing the mean of the population, sigma is known as pharmacy is less than 30, we use t-test. Testing the standard deviation of the population, we use chi-square test. This is the basic concepts in testing of hypothesis. Okay. So we have another problems also, that is testing comparing the mean of two populations, comparing the mean of standard deviation of two populations, etc. I will skip these topics because these testing procedure want more higher mathematics. So I stop here. I hope some of the ideas are clear from my lecture. If you have any queries or questions, please ask. Because some concepts want more mathematics or more statistical background. So I roughly touch with these concepts. So if you have any questions or queries, please.
Participants, if you have any doubts, you can ask that or put it in the questions in the chat box. So thank you, sir. It was the second session of a 4-day online workshop on statistical analysis and its interpretation. Sorry, sir. So here we have a question. Shall I read out, sir?
Yes.
So investigate the relationship between India. Sorry, I couldn't get that. Rajanpari, can you unmute and ask?
Yeah, sure, ma'am. Thank you. Actually, the same question which I asked that. So now I have got the Word document with me. So, sir, actually, question is investigate the relation between India volatility index with selected index Nifty index, and this selected Nifty indexes are 4 total. So can I share my screen, sir, if you allow, to show you? So exactly I can get which test I should perform actually.
Okay.
Yeah, thank you, sir. Ma'am, kindly allow me.
I think your problem is investigate the relationship between two in India with the select Nifty index. Okay.
Yeah, so yeah,
I think this is you know what is a chi-square test for goodness of it. I will explain tomorrow. Chi-square test is enough. That is the chi-square test is used for the dependency between two group of data. That is relationship between two groups. Okay. Chi-square test for goodness of it is enough.
Right.
I think so. Okay.
Sir, yeah, so sir, independent variable is VIX, India VIX, and dependent variables are total 4. I've taken.
Okay. So
yeah,
you have two groups of data.
Yeah.
Okay, two groups of data. So you want to find the relationship between these two groups.
Yeah, India VIX with banking index, then India VIX with auto index, and so on for all the 4.
Okay, so simply you go for a chi-square test for independence. Okay.
Yeah.
Chi-square test for I will explain tomorrow what is chi-square test for independence. Okay.
Okay, so sir, I need to take each hypothesis separately. That was my question actually, what I asked.
No, here the null hypothesis is there is no relationship between these two groups. Okay. Or there is no dependency between two groups. Okay. Alternative is there is some association or some dependence. Okay. After performing chi-square test, if it is rejected, it means there is no dependence.
Right.
If it is, if you accept the null, if you reject the null hypothesis, means there is no dependence.
Correct, sir. But sir, out of 4 dependent variables, suppose in auto index there exists some relation, and other 3 dependent variables does not exist relation. Then how to actually write the conclusion, because we are having only one as 0. That's what.
Okay, I think there are so many independent variables and one dependent variable.
Yes, sir. Yes, sir.
So
perfect.
You simply go for I think it is better for multiple regression or regression.
Okay. Right.
Multiple regression or regression concepts.
Right.
Okay.
But with one H0, correct? With one H0. Yeah.
Hello?
Okay. Yeah.
Okay.
Yeah. Thank you.
Okay.
Thank you very much.
So we have another question from Nekha Pandya. He said possible practical session is very useful to us. So in short time, you explain in practical demonstration to us.
Okay, I think in the last day, that is the practical session is I think Dr. Dilip will discuss some concepts with SPSS. Okay. Tomorrow also I will show how this analysis is done in R software. How this analysis is performed in R software. Thereafter, Dr. Dilip will discuss these things. That is some practical sessions. Okay. Okay. Tomorrow I will discuss how R software for some basic necessity, basic things for working R software. Thereafter, we will discuss some basics of SPSS software for statistical analysis. Okay.
Okay, sir. There is a question. Do we need to download our software?
No. No. I have just explained what is R software and how the basic statistical measures are calculated using R software, and basic statistical inferential problems are worked in R software. That is only I am explaining tomorrow.
Okay, thank you, sir. So, any further doubts? You can unmute and ask or put it in the chat box. Praveen Krishnan is raising his hands. So, do you have any questions for us?
Yes, sir. So can you hear me?
Yes.
Sir, I have one doubt, sir. Sir, what are the reasons why we are getting not normal data?
Can you please repeat? Please repeat the question.
Sir, what are the reasons why we are getting not normal data?
Actually, for every statistical analysis, we want the normality assumption. So, using CLD, we may assume that if the sample size is large, it is approximately data follows normal distribution. Approximately normal distribution. If it is not proper sampling for selecting data, that is for data collection, there are so many sampling techniques are there, probability sampling, non-probability sampling, etc. According to the nature of the population, there are so many techniques for collecting data. So, if the proper sampling is done, surely, and sample size is approximately greater than 30, surely using CLT, we can conclude that the data follows normal distribution. If the data is not random, or not in proper way of selecting data, it may have some problem. Okay, that is the assumption of the violation of normality assumption or some other issues. So selecting data is an important thing.
Okay, sir. So, if we are calculating as per the sample size calculation formula, also we can apply the central limit theorem, right, sir?
No. There is no need for calculating central limit theorem for calculating sample size. It is just a formula based on some available things. Okay.
Okay.
No need for CLT for calculating CLT. So no need for CLT for calculating sample size. It is just a formula.
Okay, sir. Okay, sir. Thank you, sir.
Okay.
Okay, those who have any other questions? Please raise your hands or unmute and ask.
Okay, I think no other questions. If you-
Yeah, okay, sir. So much. You gave a well satisfying explanation on the basic statistical concepts and its application, as well as the introduction to statistical inference. Hope it was a great time to everyone. It was highly instructing. Thank you. Thank you so much, sir. So we shall wind up the meeting. As you don't have any further questions or doubts, we shall wind up the meeting. The third session will be dealing with statistical data analysis using R. So once again, thank you so much. And all of you can leave the meeting.
Okay.